So I'm Samuel Caillou from Buildwise in Belgium, and I will present you some innovative ventilation system, which are easier to install in the context of retrofitting dwellings. And this system have been identified, optimized, and developed based on a performance-based approach and performance-based indicator, simplified compared to what's presented by the two previous speakers, but a few years ago based on, for example, CO2 indicators. This innovative ventilation system, the results of a research project based on a social housing district in Brussels, so based on real buildings in Brussels. Real building which are really common, I guess, for Belgium, but also for many countries in Europe. And this building can be quite old, with a long history. Some of the building in our samples were older than 100 years old. This kind of building have been sometimes renovated in the past, progressively renovated, and today we have to update this building to our current standard of energy and indoor air quality, but this is usually not easy. And about indoor air quality, I have first to show you here CO2 concentration monitoring in a bedroom in one of the existing dwelling in our sample. This is a dwelling without ventilation system, thus before a large renovation. As you can see, the CO2 concentration during the night, the peak during the night can be very high here, up to 5,000 ppm. So even if in a very old dwelling, the indoor air quality can be an issue, especially in the bedroom, because in previous renovation, for example, the windows have been changed and some other improvement. So even if the airtightness of the building is not so good in general, you can have a very good airtightness, for example, in bedroom, and without ventilation system, it is quite impossible to achieve a good indoor air quality. So the aim of our project was to to look at alternative innovative ventilation system, compare it to the classical one we are using in Belgium, but also in other countries, as you can see here. And the most common system for new building are for sure the fan assist exhaust ventilation system, mechanical exhaust ventilation system, and fan assist balance ventilation system with possible heat recovery. But this system in an existing building are quite difficult to install. The first problem is for sure the space needed for example, the ductwork and the ventilation unit. But also some of the installation work are quite invasive. You need sometimes ductwork and then service technical shaft to include this ductwork. And for some ventilation system, for example, mechanical exhaust ventilation system, you have to install an inlet or natural supply opening in a different room, and this is not so easy in existing building. Also, some simplified system of incomplete system are sometimes installed in existing building, but we also know that this system are not efficient enough in most of the cases. And last but not least, the cost is also a challenge in retrofitting a dwelling, and installing ventilation system is sometimes expensive. So based on different simulation work, with the aim of to look at more efficient, simplified ventilation system, we have identified different innovative ventilation systems that are easier to install in renovation. The first of the system is a system based on a mechanical balance ventilation system. in a double cascade mode, and the second one I will show you is a fan assist mechanical exhaust ventilation system, but we supply in the hallways. I will start with the first system. So this is based on a balanced ventilation system, but with a specific and innovative ventilation strategy. I will show you this on an example, a two-story house. This is a quite small house with 2 bedrooms at the first floor. So this is really a balanced ventilation system. So as the classical balanced ventilation system, you have mechanical supply in some room and mechanical exhaust in other room. But the particularity of this system is that the mechanical supply is only done in the bedroom and not, in this case, in the living room. We have no direct supply, mechanical supply in the living room. The living room is ventilated by air transferred from the bedroom towards the hallways, the corridors, and then to the living room. And of course, we have mechanical exhaust in the kitchen, bathroom, and other service room. This system is easy to install with current components on market, for sure in Belgium and other countries. You need to have classical ductwork, classical air terminal device, and some ventilation units for balanced ventilation system with heat recovery, for example. So components, classical components. So it's easy to find this component. This system can also be controlled with several possible control options. The first thing I have to say is that in this system, the total design flow rate is quite reduced compared to a classical balanced ventilation system for the same dwelling. So it's good for the energy because the flow rate is already reduced. But if we want to control more the flow rate, there are several possibilities. One of the first one is to have a central control of the flow rate based on a CO2 sensor in the living room, for example, and also a minimum flow rate, permanent flow rate in the bedroom with this central control. Other options are also possible. For example, you can add time control or other control for this system. The main advantages of this innovative balanced ventilation system in double cascade is then the fact that you don't need a ductwork and an air terminal device in the living room, which is in some existing building the most difficult to install in the real building. So it's easier to install, and that give also reduce its cost for installation because you can have a smaller ventilation unit and a bit less ductwork and component. At the same time, the system is very efficient and for sure as efficient as the classical balanced ventilation system. In terms of indoor air quality, heat recovery is also possible. And as I just said, the flow waste is a bit reduced. And last but not least, this system is not influenced by bad air tightness of the building in terms of indoor air quality. So even if in a building where the air tightness is not good or not known eventually, this system will give a good indoor air quality. Now, a few words about the second innovative system I would like to show you. So this is based on a mechanical exhaust ventilation system, fan assist exhaust system, but in this case with the supply in the hallways. Again, on the same example house with 2 bedrooms, I will show you the principle of this system. So it's a fan assist mechanical exhaust system. So you have natural supply on some place and mechanical exhaust in some room. But the difference of the classical system, here we have mechanical exhaust in each room. So also, for example, in the bedroom. And the second difference is that you don't have air inlet or natural supply opening directly in the room, for example, in the bedroom, but only at one place in the main hallways or the main corridors. This system is also easily applicable with classical components available on the market, at least in Belgium. So ductworks, air terminal device, and some exhaust ventilation unit with advanced control possibilities. And about the control, this system has a higher design flow rate, so the total design flow rate can be higher compared to a classical fan assist exhaust mechanical system. But we can here easily apply a demand control ventilation system, for example, with a local control, and a flow rate we can be regulated, controlled in each room separately. For example, based on CO2 in the bedroom, based on humidity in the bathroom, and so on. So that means in use, this system will have a very limited and reduced flow rate, which is also good for the energy consumption. The main advantages of this innovative fan assist exhaust mechanical ventilation system is also that this is easier to install in some context, because you don't need to install the air inlet in the different bedroom, for example. So in existing building where the windows have already been renovated, this is an advantage. And also a big advantage of this system compared to the classical one is that it is really much more efficient than the classical one. And this performance has been demonstrated using especially performance-based approach, simulation, and indicators. With this system, the indoor air quality is as good as in a balanced ventilation system. Why? Because you have mechanical extraction in each room, so the flow rate is really well controlled in each room, which is not always the case in the classical system. Also, you don't have any influence of lack of airtightness or bad airtightness of the envelope of the building with this system. And about the energy, this can be also very effective because we can reduce the flow rate using demand-controlled ventilation. And finally, this system can also have an improved comfort because you don't have direct outside air in the bedroom, for example, or in the living room. So you have less draft and less noise from the outside. Finally, I show a last system, which is quite a combination of the two previous systems. And this system is particularly interesting in apartments. So it's a combination of a fan assist mechanical ventilation, but in the double cascade mode. So you can see here an apartment with one bedroom and a living room with an open kitchen. You have here only supply of outdoor air in the bedroom, and this air is then transferred to the corridor and to the living room and the service room. So you don't have any direct supply in the living room. This is also possible in an apartment where the living room and the kitchen are separated, but in this case you have to add a mechanical extraction like you see a few minutes ago in the previous innovative system. So mechanical extraction also in the living room. And the main advantages of this third system is that it is more efficient in some case, and also easier to install, because you have only one supply of natural supply opening. And this is possible in apartments with a different way of a centralized ventilation system using existing ductwork in the building, or small individual ventilation system per apartment. I have, however, to mention that this system is quite sensitive to the air tightness of the building envelope, and to be very efficient, this system has to be combined with a quite good or very good air tightness of the building envelope. So that is the last system I would like to show you today. And I thank you for your attention, and I thank you the partner of the project and the organism who finance this project. Thank you, and I give now the floor to Yves Lambert.